Hello, today we will be discussing section 2.1. The topics covered in this section will be distance formula, circle equation, and completing the square. So for the distance formula, we have distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 quantity squared. Now, what does this mean? Well, it's the distance between 2 points in a coordinate system. So if I was to look at here, I'm going to say at this point here is x1, y1, and here I have x2, y2. I'm simply trying to find what is the distance between them. If we want to be really specific, we could call this the Euclidean distance, but for all intents and purposes, when I'm saying distance, just this formula here. And now, how is a way that we could view this formula? Well, I can view this formula as sort of like a triangle. And I can see that I have x1 minus x2. That's essentially my change in x. So I'm going to denote that here with a change of x. And when I look at y1 minus y2, that's again a change of y. You can think of this as a positive change or a negative change. Either way, we don't care whether it's a positive or a negative change because we're going to square it. So the consistency I have to have is where my x1 and x2 go, but I can flip these and flip these as well. I just have to make sure I'm taking an x coordinate and subtracting it from another x coordinate and not get my x's and y's turned around. So with this in mind, we can take one step further and go, hey, I kind of recognize this. If I view this as a change in x squared plus a change in y squared, that may look oddly familiar. And what's the difference? Well, I have to square root. Well, what if I square both sides? I get distance, I'm going to call d, squared. I have a triangle, a right triangle, with a change of x being one leg, change of y being a second leg, and this distance, d, is the hypotenuse. It's Pythagorean's theorem. That's all the distance formula is just an application of Pythagorean's theorem. So with this now, we're going to say, hey, what if instead of x2, y2, I'm going to fix that point. So I'm going to draw my coordinate again, and here's my fixed point. I'm going to label this h and k for reasons we'll see in a second. And for this point, we're going to have this change in x, change in y. Well, this gave us kind of a distance d, but what if I fix it and I kind of swing this point away? So I'm making other little triangles as I kind of move this point, and then I get a line of distance 1, and then I can kind of keep going all the way around. Well, what if I continue? It's going to look something like that. It's a circle. Okay, well, this distance again, I'm going to call d, but with the circle, we're going to now relabel this as r. So I now have r squared is equal to whatever this point is. It could be here, it could be here, it could be here. I'm spinning it around. I don't know exactly where that point is, so I'm just going to label it as x. Well, my change in x from this point on the circumference versus the center, well, that's just minus h, the x coordinate of the center. And now I'm going to square that and add y minus k. I'm going to square that. And I still have my change in y, my change in x, and here's my distance, but I relabeled it as r because it's the radius of a circle. Oh, this kind of looks like this, which kind of looks like this, which is Pythagoras theorem. We're just using it and modifying it a bit. So simply by knowing Pythagoras theorem, we can generalize this distance and go, oh, that's what that is. We can look at a circle and go, oh, just Pythagoras theorem with the fixed point, we're spinning one side around, one of the points around. Okay, well, how is this useful? Well, what if I was to give you an equation that looked like this? 4x squared minus 8x plus 4y squared plus 6y equals 6. And I said, I want to know what this equation is doing. Can you describe what this equation is doing? Well, we would need some way of making this simpler and something we understand. Well, I see an x squared, I see a y squared. They're times by something in front of them. So let's see if we can get them by themselves, that x squared, y squared by itself. So I'm going to divide this entire thing by 4. And I get x squared minus 2x plus y squared plus 3 halves y is equal to 3 halves. Now, I can start to see, hey, it might look a little like this. Well, in order to get it into that form, we're going to have to use something called completing the square. Now, if I was to take this x minus h, I'm going to have x minus h squared. And I'm going to say that that is equal to x squared minus 2hx plus h squared. This is one of the formulas that we had in a previous video. However, you can derive this by just having x minus h times x minus h and FOIL, or as I prefer, double distributive. And now let's write one for the y. Y minus k squared is equal to y squared minus 2 ky plus k squared. So we now have sort of a roadmap to connect these two ideas. But first, we have to make it look, we have to make it look a little bit more like that, because we have this kind of negative 2x. Well, that looks kind of like this negative 2hx, but where's this h term coming from? How can we find it? Well, for completing the square, and this is the method that we'd use for this, we can kind of pick that apart. So we can consider x squared minus 2x. That looks similar to this expression here. So I want to take a look at that exponent and say, or that coefficient here, and say that negative 2x must equal negative 2hx. We want to solve for h. So we're going to cancel out x. Now, notice I use the word cancel. I didn't divide by x because x might be 0. I'm using cancel because, well, if I times this side by x and times this side by x, well, the coefficient must be the same. In other words, negative 2 is equal to negative 2h. And now I divide by negative 2, divide by negative 2, and I have h is equal to 1. All right. Well, so that means what I could do is I can have x squared minus 2x plus 1. And I know that this quantity here can simplify into x minus 1 squared. However, I can't just add 1. I got to subtract 1. I got to keep it even. So I'm going to subtract 1 from the final solution here as well. And I'm going to keep track of that. So now next one, I'm going to do the same thing with the y's. So we're going to consider y squared plus 3/2 y. Well, we get, again, we're going to try and compare this term. So we're going to have 3/2 y is equal to negative 2k y. We're going to cancel out the y. And now we have 3/2 equals negative 2k. Divide by negative 2, divide by negative 2. Now here, this becomes negative 3/4 is equal to k. So that leaves us with y squared minus, or sorry, y squared plus 3/2 k plus, now why am I adding? Because I should have mentioned this before. This k, we are going to have a k squared. So I can just fill this in as negative 3/4 squared. Now I'm purposely going to leave it as negative 3/4 squared, and you'll see why in a second. The reason why that I didn't do the square here is because, well, I had 1. So 1 squared is 1. But anyways, I want a positive version of this. Oh, sorry, this will be a positive version, so I need to offset it. So I'm going to have a minus negative 3/4 squared, just like that. And so this gets us to have y minus a negative 3/4 quantity squared minus a, that would be a 9/16. Okay. So now let's combine these two things. And we get x squared minus 1 quantity squared plus 1. Let me actually lower this a little bit. X minus 1 squared plus 1. No, minus 1. Minus 1 plus, well, we're going to have y minus negative 3/4 quantity squared. We're going to minus 9/16. And all of that is equal to We haven't touched the other side of the equation, so we're going to put 3/2. So what we now need to do is bring whatever is not in a parenthesis into the other side. So I'm going to add 1 to the other side. I'm going to write this with a +1 here. I'm going to add 9/16 to the other side. Plus 9/16. And now I'm going to take this and simplify the right-hand side. So I'm going to have to make them common denominators. So for the 2/3, I see a 9/16, and I see a 1. So if I times the top and bottom by 8, I get 24/16. That's 3 times 8 divided by 2 times 8. So that's how I got 24/16. Plus 16/16 plus 9/16. And 24 plus 16, that is 40, plus 9, that's 49. I get 49/16. And now I'm going to rewrite the equation. So I have x minus 1 squared plus y minus a -3/4 quantity squared. And I'm saying that this is equal to 49/16. So this is when we look back at the original question and say, hey, I want this equation. I want to make this understandable and tell me what's going on. I want you to tell me what is going on in this equation. So we know that it looks like a circle equation. And I'm seeing h is 1, k is -3/4, and then I have this 49/16. What is that? That's equal to r squared, meaning we have to put this number on the right-hand side in terms of a square. Well, 49 is 7 squared, 16 is 4 squared, so I can rewrite this as 7/4, and that quantity squared. So this means that my radius is 9. So I could write that as h equals 1, k equals -3/4, r equals 7/4. I could box that in my answer, and I'd say that you got most of the points, not all of them. And here's why. This doesn't tell me what's going on. Instead, what we can do is take this information, and leave that there because I'm just going to write a sentence, and say the equation for x squared minus 8x plus 4y squared plus 6y equals 6 is describing a circle centered at the point. I'm going to put it in point notation. What's my point? Well, it's HK. That describes the center of the circle. So What's my h? 1. What's my k? -3/4. So I'm going to write 1, -3/4. I'm going to look back and say, okay, where am I at? I'm centered on the point, 1, -3/4, with a radius of 7/4. 7/4 what? Units. Huh. This answer here is what would get you full points with, of course, the work to show it. Okay. For the check your learning or your weekly check-in, what I want you to do is just rewrite this statement verbatim, and that will be your check on learning. Thank you. Thank you for watching, and have a great day.